A gas occupies a volume of 22.0 liters per mole at STP. Which of the following explains the deviation from ideal behavior? A. Predominance of attractive forces among the molecules. B. Predominance of repulsive forces among the molecules. C. Absence of attractive forces among the molecules. Or D. Absence of repulsive forces among the molecules. A gas is said to be behaving ideally if it obeys the equation PV equals nRT. One way we can tell if a gas is behaving ideally is by comparing its actual volume to the value predicted by this equation at the same temperature and pressure. We can rearrange the ideal gas equation to solve for the molar volume. The molar volume, or volume per mole, is equal to RT over P. If we plug in 1 atmosphere and 273.15 Kelvin, the pressure and temperature at STP, we find that the ideal molar volume at STP is 22.4 liters per mole. The actual molar volume at STP given in the problem is 22.0 liters per mole. This is less than the ideal value of 22.4 liters per mole. So how do we explain this deviation from ideal behavior? Deviation from ideal behavior is mainly due to attractions and repulsions among molecules. Remember, molecules are made up of charged particles. Positively charged nuclei will repel one another, but attract electrons. Negatively charged electrons repel one another, but will be attracted to the positive nuclei. Therefore, there will always be attractive and repulsive forces among molecules. Obviously, choices C and D are incorrect. Ideal behavior is observed for all gases at very low pressures because the average distance under these conditions is very, very large. Under these conditions, attractive and repulsive forces among molecules, even though they exist, are negligible. This is the reason why PV equals nRT works, regardless of what kind of molecules you have in your gas sample. But it only works for as long as we're dealing with very low pressures. So what happens at higher pressures? In these cases, the average distance between molecules is such that attractions and repulsions among them are no longer negligible. Attractive forces would tend to make molecules stay closer together. This would result in the gas occupying a smaller volume. Compared to the ideal case where the molecules do not interact at all. On the other hand, repulsive forces would tend to make molecules stay farther away from one another. This would lead to a larger gas volume, compared to the ideal case where the molecules do not interact at all. In fact, at very, very high pressures, repulsive forces become predominant, and the volume of the gas would be larger than ideal. Since in this question we are given that the molar volume is less than ideal, we can conclude that for this particular case, The deviation from ideality is due to the predominance of attractive forces. Therefore, the correct answer is choice A. Note that different gases will behave differently under the same conditions. The deviations would depend on the strength of the intermolecular forces, which depends on the structure of the molecules.